the University of Minnesota. I'm a barley breeder, among a few other things there. And now we need to turn it up. All right. Don't make it squeak. No pressure. How's that? How about that? Good. Okay. Hopefully this will work. All right. So Scott asked if I would talk about winter barley, and I think what he was asking for was some kind of a presentation that would get at, where is the potential for winter barley? There's been a lot of interest in winter barley. There's been some expansion of the breeding that's happened across the U.S. And so I thought it would be a really good opportunity to take advantage of some trial data that we have been collecting or coordinating over the past 13 years now in this winter malting barley trial, to sort of do a big picture look at what's happening with winter barley. So that's what I'm going to talk about. This is a picture from a field day that we had this past summer, where you can see our winter barley plots and spring barley plots in the same slide. You can see some obvious differences in those two crops in Minnesota. Much earlier maturing. So we started harvesting our winter barley the end of June, like June 30th. And we wouldn't be harvesting the spring barley until at least 2 weeks later, 2 weeks and a few days later. So it's planted in, as was said previously, it's planted around the 1st of October. The fall barley, the spring planted barley is planted, in mid to late April usually. And so there's some very big differences in terms of that planting window, in terms of when maturity happens, and when there's actually plants on the ground, sort of creating that cover on the landscape. And so those differences between spring and winter barley, I think, offer some interesting opportunities to exploit that in our agricultural production systems. The mouse, okay. All right. So I'm not going to go into this whole list, but these are usually items that come up when people talk about why should we think about winter barley. Particularly, I'm thinking about regions where you have a choice between spring and winter barley in a particular region, like we do, in the Midwest and other regions. So winter barley has the potential to expand the production area. I think that was pointed out really nicely in the previous presentation when Nicholas showed, how little is grown east of the Mississippi. Those are a lot of the regions where we're actually testing or evaluating winter barley. There's a potential to improve nutrient cycling. I'm involved in a larger collaborative initiative called the Forever Green Initiative at the University of Minnesota. And the goal of that initiative is to produce cropping systems that produce continuous living cover. So either perennial crops or combinations of winter and summer annual crops where you have plants on the landscape the whole year to reduce erosion, improve nutrient cycling, and most of all to help protect water quality. With spring barley in the Midwest, we often have to wait in the spring to plant because the ground is too wet. Obviously, if you've got your plants in the ground already, you don't have to do that. I'm going to talk about some of the productivity or yield potential in winter barley and some of the trial data that we have. We have a lot of regions in the U.S. where the portfolio of crops is pretty limited. In the Midwest and Minnesota, sometimes it's just two. So adding small grains to that portfolio in some way that's meaningful and makes sense to a producer is a way to diversify that. Spreading out the farming operations in terms of when you're planting, when you're harvesting, because as a farmer, you're managing multiple crops. And then it was also alluded to, I think by Nick as well, there's a possibility of, because you're moving up that harvest date, that maturity timing, possibility of avoiding disease. So I'm just going to probably just touch on a couple of these just to illustrate what I'm talking about. So this is a chart that's showing nitrate levels in surface waters in Minnesota, and all of the red dots are the high levels of nitrate. And so there's clearly a problem and major concern in Minnesota with nitrate levels in both surface waters and groundwaters and wells. And there's a lot of interest and incentive in finding solutions. And a lot of that nitrate is coming from agricultural systems. So we can change those systems and reduce that nitrate leakage. We can have a substantial impact. And I think winter crops and winter barley is one place where we can do that. This is a slide from an experiment we did actually 2 years ago. It's a double cropping experiment we did with winter barley and soybean. And you can see the two sort of major treatments. We had some other treatments in there as well. But you can see this is a picture that was taken June 9th. We took soil samples at the same time. So at the time when the barley crop is fully headed out, our normal single cropping soybean system is basically just emerged or hasn't emerged for very long. And there's a substantial difference in the nitrate level in the soils at that particular time. And so this is a time when that nutrient leakage is much more likely to happen, the risk of that happening because of the wet springs and snow melts and things like that that are happening in that early spring period. The other one that I'll talk about is the potential for winter barley to avoid certain diseases. So we talked a little bit about fusarium head blight already. And what I'm showing you here are graphs that are produced by the Fusarium Head Blight Prediction Center. So this is a prediction model that was developed by researchers supported by the U.S. Wheat and Barley Scab Initiative that lets growers know when the risk for fusarium head blight is greatest. And this is a tool that's used by farmers to make decisions about whether a fungicide should be applied. So they can look at the stage of their crop, they can look at the particular risk at any particular time and determine that risk. And so if you pay attention to, say, Minnesota and New York, for example, in this series of slides, you see that winter barley is heading around the end of May in both Minnesota and New York. I talked to Mark Sorrells and confirmed that that was about the same time. And at that time, there's very little risk, and even the weeks that follow, little risk according to the risk prediction model. But then the risk prediction becomes greater in June, mid-June, in New York at least, and that's when spring barley is heading. And so clearly, at least this is just anecdotal evidence. This is 1 year with prediction data, but this would suggest that, again, moving that flowering time up, that window of time of vulnerability might allow us to avoid this disease, which has been a really difficult disease to manage through either breeding for resistance or applying cultural practices. So I'm going to try to follow up with this by looking at model predictions for other years and see if this trend is reproducible over multiple years. So the where part of this. So that's kind of the why, why we were considering it. So the where part of this, what I thought I would try to do is take advantage of regional trial data that we have for both winter barley trials and spring trials, and ask the question, where we have trials in the same location, winter and spring barley trials in the same location in the same year, is there an advantage of winter barley in terms of yield over spring barley? So I utilized the winter malting barley trial, which is one that we've coordinated for the last 13 years. All the little red stars are locations. There's even more than that, but those are most of the locations where the trial has been run at least sometime in the last 13 years. There's also a trial that was run, coordinated by Rich Horsley, called the Eastern Spring Barley Nursery, which was primarily locations in the East. And again, those were spring trials, so I could use those. And they were often run in the same locations as the winter trials for the winter malting barley trial, so I could use that as a data set. And then there are individual state trials in Oregon, Idaho, Utah, Wisconsin, Minnesota, and Michigan that I could draw on as well from Collaborate. So it's not a complete data set. I'm sure there are other data out there. It's also not it's not a perfect data set because there's a lot of caveats, right? So there are different varieties in spring and winter trials. So I'm going to use the trial average yield as an estimate of what the potential is, but there are different varieties, and there are different years where we can make comparisons in any one location. And we know that years vary dramatically in terms of what that production might look like. But nevertheless, I thought it would be a starting place to kind of do that comparison. So I calculated this thing which I just called the winter advantage, and it was just simply the trial average in bushels per acre from the winter trial minus the trial average for the spring trial in that location in that year. I'm going to zip through these slides and show you some of the locations where we could look at this. I calculate that winter barley average or advantage for, in the case of Oregon, had data we could look for 4 years. 3 of the 4 years we saw a fairly substantial advantage, with an average advantage over those at that period of time of 23 bushels. Similar kinds of data from Washington over more years where we could make that comparison, average of 27 bushel advantage of winter over spring. Idaho is interesting. We got data from Juliet Marshall, and she's been conducting spring and winter trials sort of side by side for a number of years. And so actually to look at 2 different locations within Idaho where she does that trialing. And one of the locations that averaged 21 bushel advantage, the other one was pretty much break even. So clearly the location is going to have an effect. I don't know what's explaining the difference between these 2, but I think one of the things that would be really interesting to do with this sort of data is to really dive into what are the environmental factors at all of these different locations that might be driving the differences between, spring and winter production. And I think that's something that we started to accumulate some of that environmental data, and just need to find a person who will be able to spend enough time to work with it. So we can zip over to Minnesota. Of course, Minnesota has some additional challenges with respect to winter barley. And we do get years where we don't get winter barley to survive. And so those are the ones that are kind of grayed out there. So I only used data when we had survival. But at least in the years where we had survival, the average was still a 10 bushel advantage of winter over spring. And in the years where we had very good survival, particularly like 2021, the advantage was quite large. So it can be very substantially variable from year to year, depending on that winter. Michigan was pretty consistently a strong advantage, and I think that's aligns with sort of the anecdotal other evidence from that location. New York, a little bit similar to Minnesota. There are some years with winter kill, not quite as severe. But again, that average over years was about a 22 bushel average. And then the last one again was Vermont. Vermont has some challenges with winter survival as well. But even so, at least in those years where survival occurred, there was a positive advantage on average. So just looking, sort of stepping back and looking at all of this data together, I tried to kind of give a little conditional formatting summary of this, and you can see the location sort of ranking from the lowest survival, which is Minnesota, all the way to the highest survival, which is in Oregon. So there's a whole range of winter severity in there. The bottom set of locations are locations where we don't have a spring barley comparison because they only are growing winter barley in those regions. We don't have spring trials to, at least that I could find or know about, that we do comparisons with. But so you see, for the most part, winter survival is not an issue except for Nebraska, where they do get some winter kill. If you look at the yield, this is the yield in bushels per acre. Again, it's quite variable, but it just ranges from 70 bushels up to 156. So pretty substantial yield possibilities even in these winter locations. The N is obviously the number of trial locations, and so that also has an impact on what those numbers look like, because if you happen to be testing in the last 3 or 4 years where the winters have been mild, obviously that advantage is going to be greater. The Idaho locations, one thing to notice, those are irrigated trials. So certainly irrigation is going to have an impact. And I think there's going to be a presentation later in the conference that's going to talk about irrigated winter trials. And then interesting, the more southern locations where really only winter barley is grown, for the most part, those yields are not as competitive as the northern location. Virginia does quite well, but there are other locations that are sort of below the average of the northern locations. And then I just have the actual spring yield comparisons, and then just the last column is just a repeat of what I just walked through. So again, it's messy data. There's some caveats there, but in general, I think we can agree that there is going to be an advantage overall. It's not going to be the same in every year in every location, but I think it means that we should continue to think about how we can take advantage of that. So then the last part of this I'm going to talk about is just a little bit about the how. So how can we expand, if we think it's a good idea to expand winter barley production? And I think others have brought up the idea that having barley grown over a broader geographic region could provide more resilience and more stability to the supply chain in general, if we're not relying on barley to all be produced from a couple of limited concentrated locations. One of the things that we need is more sort of real world experience. So this is an example of a case study that was done with a guy named Chris Wilson, who has a farm in Cuba City, Wisconsin. It's an organic production farm. You can sort of read some of the details there. I'm not going to go into detail, but I met him a couple of years ago, and he's been doing the last couple of years winter barley and soybean double cropping in southern Wisconsin, and he's had pretty good success. And so, what has that looked like on his farm? And we just look at the bottom part of this chart here. That's a comparison in 2023, this past year, between full season soybean and double cropping barley and soybean. One of the biggest advantages that he finds in this system, particularly for an organic production system, is fewer passes through the field to do weed control. And weed control is obviously the most difficult thing to do in an organic system because you don't have access to herbicides. So he has a much smaller cost in terms of those management practices. He got 47 bushel per acre soybeans in the single cropping system. He got less yield in the double cropping system, but that's not unexpected because we're trying to get two crops in the same year. So he got 33 bushels in the soybean, but then he got 90 bushel of barley, which is really quite impressive for an organic system. And so his net profitability was quite a bit larger for the double cropping versus single. Again, this is anecdotal. It's 1 year. It's probably not going to happen every year, but this is the kind of information that I think we can collect if we work with growers that are implementing these systems. And this grower was very happy to share all kinds of information about what they were doing, and we're trying to seek out others that could do the same sort of thing, so we can get a realistic picture of what that value might be to expand the production of winter barley. Another thing that I think feeds into the how, if we want to expand this, is to reduce the risk associated with winter barley, particularly in regions where winter survival is an issue. And this is an example of a very, very small program. It's, again, part of this Forever Green initiative. It's called the ECO program, and it's basically like a mini crop insurance program for farmers that want to try to grow Kernza, which is a perennial crop, or one of the winter annuals, which includes winter barley, as part of a double cropping system in Minnesota. And we've identified particular areas where where farmers could apply to this program. It doesn't cover a lot of acres, but it gives them sort of this ecosystem benefit payment, and then an economic risk benefit, which covers half of their inputs if they have a complete failure. So it's not going to cover them completely. It's probably not as good as the insurance you get with corn or soybeans, but it's much better than what they have currently. Another thing that would help is for there to be a greater market for winter barley in these regions. And so this was actually kind of a surprise to me. I went to the AMBA website to see, well, how many winter varieties are on the AMBA approved list? And there was more than I thought. I mean, 10 years ago, I think there might have been one. So they're out there, but they're contracted on fairly limited acres. So I just highlighted basically Thunder and Wind Malt as the two varieties that are winters that are being contracted, and they're on fairly limited acreage. But if there was incentive for farmers to grow it and contracts available, that would be another way to expand the production on the landscape. I kind of talked about this before, but I think there's a lot of opportunity for expanding cropping systems research. So how do we implement these systems and take measurements that will produce information that will help farmers make decisions about when this system would make sense. So we've expanded this winter barley double cropping experiment on our campus. We've done it for 1 year. We're going to do it for a second year. This is just kind of what that experiment looks like over time. And in addition to measuring the productivity of the system, measuring the yields, we're also measuring nitrate levels in the soil and in soil water with lysimeters. So we're trying to monitor that nutrient cycling and that potential risk of nutrient loss in that system. So if we can measure it, we can attribute some value to it, in addition to the bushel value of the crop that's produced in that system. And then the last thing that I'll mention that's part of the how, particularly in Minnesota and other places too, is to improve winter hardiness, improve low temperature tolerance. And this is a description of a project that is being led by Brian Stephenson's group. Basically, there were 2 very large GWAS studies that were done to look at low temperature tolerance. And they're shown in the upper left corner there, or left part of the slide. They identified a lot of QTLs. 5 of them were in common, but there are a bunch of different QTLs. And that information then was used to select a set of parents that had all of the favorable alleles at those QTL at a high frequency that also kind of represented the diversity of that collection. And those parents were selected to make a magic population. So 8 parents were selected. Those were the 4 crosses were made amongst the original 8 parents. Then those F1s were crossed, then the F1s of those were crossed. And then we did single seed descent to produce some inbred lines. So out of that magic population development, we have 653 facultative lines that were planted this fall in 7 locations, including 2 in Minnesota. We have other lines that are sort of trailing behind. There are additional facultative lines and also some true winter lines. But the hope is that this population should represent sort of the, hopefully or possibly, the genetic sort of maximum potential of winter hardiness in cultivated barley. And so we can hopefully derive lines from this or use them in crossing, and they will all be available for that kind of research. So I will stop there. And I just wanted to put up as an acknowledgement slide a list of all the folks that have been involved in the winter malting barley trial over the past 13 years, and there are lots of them. And this is a project that wasn't supported by some CAP grant. We do have support from AMBA, which I'm grateful for, to coordinate the trial and send out seed and that kind of thing. But basically, this is a group of volunteers that agreed to grow this trial because they wanted to better understand the potential of winter barley in their regions and use that information to help agronomists and extension agents sort of make or not make the case for winter barley in the region. And so it shows that I think this is a really rich data set. I'm hoping to exploit it more than just sort of the simple analysis that I did here, but it's an example of a way to take advantage of these large collaborative efforts that are really sort of a natural part of the barley research community. So I will stop there and be happy to take any questions if we have time.
So back in 2013, probably really been happening.
Yes.
Get this figured
out. Yeah, so the question is about the possibility of another CAP grant. Yeah, actually 2 years in a row, we tried to put together a CAP grant and we're not successful. It might be. At the time, one of the criticisms of that effort was, that barley was, sort of a minor crop and it wasn't going to have a big impact because there's not a lot of acres. Since then, there have been CAP grants funded with crops that have much, much fewer acres. So, it's hard to tell what the thinking is, but it's possible that might be a time to revisit that. Yeah.
cover crop programs that their race. I don't know, I mean, that's what costs. Talking about the insurance at $100 an acre. We have cover crop programs, and all I gotta do is well. So I talked to a lot of growers. Why would I ever grow wheat ever again? Why would I grow barley? But all I gotta do is sponge the garden dry, throw it out there. And get $110 to $150 an acre.
Yeah, I mean, I haven't, I mean, this is a brand new program, so it will be interesting to see what the reaction is. This program really appeals to farmers that are kind of the more risk taking kinds of farmers that want to do this for other reasons, right? They're not just doing it for monetary reasons or for for a government payment. They want to do it for other reasons, but I think still it might be useful to sort of hear what their reaction is to it. Yeah. Go ahead.
The contract growing.
Right, and that's my point. I mean, there are approved varieties that are out there. There's some limited contracting that's happening, but certainly, more contracting and more opportunities for farmers to market that grain at a profitable price is gonna be a big driver. And that's really, I mean, this Forever Green initiative that's really looking at these alternative crops that are perennials, and they're mostly crops that need a lot of that market pull. And a lot of the work that's going into that initiative is trying to figure out how to do that. How do you generate that market pull and make it a win-win? Yes, Pat.
Yeah, it's exciting to see that 8-parent magic population and that it's facultative. Are you still like a firm believer in facultative barley relative to, say, the winter barley that require fermentation?
I have not seen any reason to believe that the facultatives are, paying any sort of penalty for being facultative. One of the things that we're going to do with this magic population is derive some nils to really, definitively test in a near isogenic background, facultative versus true winter, and see what those look like. So I don't think I'll be surprised, but it will be an experiment that I think we can do with a lot of different nils that will allow us to really kind of nail that down. Yeah.
One more.
So you said 207 locations for the magic population after this setup.
Yes. Well, this was mostly organized by Brian Stephenson's group, and it was basically finding volunteers. Like it was those who are willing to do it. It's if you want to grow 700 some lines and screen for winter hardiness and collect the data and send the data back. We had limited amount of seed this year, so we could only do 7. And they're Nebraska, Minnesota, Montana, Idaho, and where? Ohio. Okay, yeah. So in Ohio still. And Cornell. Okay, great. Thanks, Ahmed. So those are the locations currently. We should have more seed available for this coming year, so that if anybody else is interested in growing it out, we'll get you the seed and do it. Great, thanks.